Okay, this is unit 8.4, area between curves. So the idea of what we're going to do is find the area that's in between two curves like you see here, bounded by g of x on top and f of x below. Now the whole idea is if we take the integral of g of x, that is all of this area here. But again, we want to subtract off this extra area, so we're left with the area between f of x and g of x. So what we need to do is subtract off the area of f of x, which is all this down here. And if we do that, we're left with the area that we're looking for. So there are two main points. We do need to determine which area is above. Which function is above and which function is below, because we do need to take the uppermost function and subtract it from the lowermost function. And we need to know the intersection points that I labeled here as A and B. So we're going to do this by hand and with a calculator. So if you look at example 1, we're trying to see the area bounded by f of x and g of x, and the equations are given right there. Now, if we have a graph, we can kind of see that is between, like, the intersection points are -2 and +2. So if we were just to set this equation up, we would say we want the integral of the top function, which in this case is g of x. And we're going to subtract off the lower function, which is f of x. And we want to do that from -2 to 2. And this is what we are doing here. So if I substitute the values in, so g of x is going to be 2x plus 5. And then we're going to subtract off f of x, which is x squared plus 2x plus 1. Now, let's simplify this function. So we're going to get a negative x squared. And then we're going to get a minus 2x, which will cancel with this 2x. And when we distribute the negative through, we're going to get minus 1. And so this is going to be 5 minus 1, which is plus 4. And then if we do the integral, so let's do the first piece, we're going to add 1 to make that 3, and then divide by 3. And the integral of 4 is just going to be 4x. And we want to evaluate that from -2 to 2. And so let's just plug in our values. So plugging in 2 here, we're going to get 2 cubed, which is 8 over 3. And then if I plug in 2 here, that's going to give me plus 8. Subtract. Now we're going to plug in -2 here. So -2 cubed is going to be -8. But it combines with this negative to make a positive 8 thirds. And then plugging in -2 here, you're going to get 4 times -2, which is -8. And then if we go ahead and distribute, this is going to be -8 thirds plus 8 minus 8 thirds plus 8. And then this is going to be 8 plus 8, which is 16. And then we have minus 8 thirds and minus 8 thirds again. So same denominator, so just take the numerator. And you're going to get minus 16 thirds. And there you go. There is my area between the two curves. And that is this area here that I'm going to shade in yellow. And there we go. We did it by hand. The only thing we didn't do is sometimes we're not given a graph. And so we need to find the intersection. And the way you do it is you set the equations equal to each other. So if you want to find out where these two functions intersect, you need to set them equal. So let's substitute the equation in for f of x. And then g of x is 2x plus 5. Now, if I subtract 2 of x from each side and subtract 5 from each side, that's going to give me x squared minus 4 equals 0. And then if I add 4 to each side, I'm going to get x squared equals 4. And then when I square root, I'm going to get plus and minus 2. And again, that is those intersection points that we see there. Okay, going on to the next question. Same type of function. Now notice that we do see that their intersection points are at 3 and 0, right? And we're finding the area between the two curves. Now this upper equation is going to be the parabola, the negative x squared, and this straight line is going to be x plus 2. So if we were writing the integral, it's going to be from 0 to 3. And the uppermost equation is negative x squared plus 4x plus 2. And we want to subtract it from the lower equation, which is x plus 2. And then we proceed the same way. But let's stop for a second. Let's go back up and let's find the intersection by hand, just in case we don't have a graph. So again, we're going to set the equations equal. Okay, and then solving, we're going to subtract 2 from each side, and those go away. Subtract x, and those go away. So we have negative x squared plus 3x equals 0. And then if I factor out a x out of here, let's factor out a negative x to make it easier. We're going to be left with x plus 3 equals 0. And again, if I set this equal to 0, I get, oh, I'm sorry, I made a mistake. This right here would be a minus, because I did, again, I factored out a negative x out of here, so a negative x out of here, leave it as minus 3. You can always check by redistributing. That would be negative x squared, and this would be plus 3x, is what we have. And then, again, if I set this equal to 0, I get 0. And if I set this equal to 0, I get 3. And those were my boundaries that I found on the graph. So returning, we want to simplify this equation a little bit. So my negative is going to distribute to both of these terms. And so we have negative x squared. That's by itself. We're going to have 4x minus 1x, which is 3x. And then here we have 2 minus 2, which is 0. So now let's do the integral. Well, I guess I technically should write, to be formal, that this is dx. Now if I take the integral here, I'm going to add 1 and then divide by 3. And then since this is a 1, if I add 1, I get 2 and then divide by 2. And then I'm going to substitute 3 and 0 into my equation. So plugging in 3, I'm going to get 3 cubed, which is 27, over 3. And then plugging in here, I'm going to get 3 squared, which is 9, and then times 3, which is 27 again, over 2, minus. And then these ones, I'm going to plug in 0. That's going to give me 0 over 3. And then plug in 0 here, and that zeroes that function out. And so we are just left with this equation right here. And again, this will be 27 over 2 minus 27 over 3. And you can combine that if you want, but I'm just going to leave it as is. That is my area between my two curves. That is here. And then you might see this on a multiple choice. They might combine this into a single fraction. Well, I guess you could say that that's 9. 27 over 2 minus 9, which makes it slightly easier. All right, example 3. So this is a calculator problem. Now, we're given these two functions. Now, in a graph, I did graph it here, but I'm going to show you on the calculator. But this is what the graph looks like. I didn't even highlighted them. This is this function. Now, this does increase, but at least for the window, I'm just looking here. And then cosine is in blue. Now, here we have two separate areas. We have this area plus this area. Because again, it's asking us for the total area enclosed by the curves. So if I want this area, that's going to be the integral from whatever a and b are, and we will find those in a second. And that is going to be f of x minus g of x plus the area of this region, that's from B to C. And again, that's B and C, and I just labeled these as arbitrary values to make my notation a little bit cleaner. And the topmost function is the cosine one, which is g of x. We're going to subtract the lower function, which is f of x. So this is my integral that I'm doing. I just need to find out what a, b, and c are, and then use my calculator to solve this. So in my calculator, I labeled this as y1 and y2. So this is y1, y2, and y2, and y1. But let's go to our calculator and see. So as you can see, here's my functions. Now, if I go to graph, if you want to zoom in, go to zoom. I don't have it on mine, but zoom box allows you to create a box to zoom in. But this, as you can see, is what I graphed. Now, I do need to find these intersection points. Now, the way to do it is we need to go to calculate, which is right above the trace in blue. So you have to hit second, trace. And then this is if you want to calculate any value, x-intercepts, minimum, maximums, intersections, derivatives, or integrals. But in our case, we want to do the intersection. Now, the calculator doesn't know where we're looking at. There's multiple intersection points there. So we have to narrow it down for the calculator. So it does say, where is your left bound? So we want to go to the kind of the left of the intersection point, which I can't see it on here, but that should be good. And right bound, oh, there it is. Right bound, so we dragged that line to the left and to the right of the intersection, and then it tells us that it's 2.6743. So we'll note that, and then we have to do that for every other point. So again, you'd go to second, calculate, go to intersection. So since if we want to do the middle right here, it says where do you want us to look? So you got to set kind of a left boundary and a right boundary, and it will find the intersection point for you. So that's good. Now right bound, to the right there, hit enter, and then we see that that's 4.6436. And the last point, I'll let you do by yourself. Okay, and there are my 3 intersection points of the graph. And then now we just need to type this in as an integral. We do have to plug in these values for a, this value for b when we're doing the integral, and we can use y1 minus y2, and then we're going to add the integral from b to c, with those being our values for b to c, and then we're going to do y2 minus y1. So let's go back to our calculator. Now again, we want to do the integral, so go to math. Number 9 is integration. Plug in those values for a and b. And then again, we are going to do, what is it? Y1 minus y2. So go to variables, over, functions, y1 minus y2. Now, in your calculator, I made this mistake. Make sure you hit over another time so you're not just sitting here next to the x like this. It always gives me a weird answer, or it says invalid. So just make sure you click right once. And then we're going to do the integral again. Hit enter, and then that's what we get for our area, 0.8021. And again, that is my area found in the calculator. And on a free response question, this is enough work to show. All right, again, so example 4, we're given a graph of f of x equals the square root of x, and g of x is equal to negative 1/2 x plus 4. Determine the area enclosed by these graphs. So from here, I mean, it's not really necessary to find the intersection points because we can see it. It's at x equals 4, but let's just verify algebraically. So we did set them equal. Now we need to solve this. Now, I don't like working with fractions, so I'm going to multiply everything by 2. Now this is going to multiply. This is going to become negative x. And when we multiply here, that becomes plus 8. Now, we want to square each side. Now, on the left, that's going to be 2 squared, which is 4. And then the square and the square root cancel. So this is just 4x equals. And then if I distribute the right side, we're going to get that is x squared minus 8x minus 8x again, which would mean minus 16x, and then plus 64. And then if I get the 4x over to the other side. Okay, so now we do have to factor this. This looks like what numbers multiply to 64 but add to 20. I think that's 16 and 4. Which gives me 2 intersection points at 4 and 16. Now notice 16 is out of the domain, so we cancel that out. So it is just 4. We did verify. Now, that was a lot of unnecessary work, but I think it's great to practice the algebra. But yeah, so we want to find the area under the curve here. So that's the integral from 0 to 4 of x to the 1/2. And again, I'm writing this as an exponent of 1/2. And then this is the integral from 4 to 8 of negative 1/2 x plus 4. Now, we actually don't need to do the integral. We can look at the area here as a triangle, but we'll do it the long way just to show it. Okay, so now if I take the integral, if I add 1, I'm going to get 3/2. 1/2 plus 1 is 3/2, and then divide by 3/2. And we're going to plug in 4 to 0. Plus, if this is a 1, so add 1, that becomes 2, and then divide by 2. And then here, if you take the integral, that's just 4x. We want that from 8 to 4. And again, we could clean this up. This will turn into a 4. But let's plug in. So we have 4 to the 3/2. Actually, let me clean it up first. Let's pull out this. This will become a 2/3. So we x to the 3/2 from 4 to 0. It is a constant, so I can pull it outside. Plus, this will just turn into negative x squared over 4. plus 4x, 8 to 4. Okay, so if I plug this in, what is 4 to the 3 halves? Again, remember that this is the square root, so I can rewrite this as the square root of 4 cubed. So this is going to be 2 cubed, which is 8. And then when I plug in 0, I get 0. So this is 2/3 times 8 minus 0 as the first part. Plus, if I plug in 8, I get 64. 8 squared is 64. Divided by 4 is 16. This gives me negative 16. And this is going to be plus 32. Subtract. And again, if I plug in 4 here, that gives me 4 squared, which is 16. Divided by 4 is 4. So negative 4. And then if I plug in 4 here, I get 16. And then so this first part is going to be 8/3 plus. Now we have, this is going to be 16. This is going to be 12. So 16, this part is 16 minus 12, which is 4. And there we go. There is my answer. Now again, a much easier way of doing this problem is knowing that it's a triangle. So it's 1/2 base times height. My base is going to be 4. And the height is 2. So we could have just easily said, oh, that's 2 times 2, which is 4. That was this answer right here.